All right, station 4, the one I had a little bit of an error I messed up on. I'm sorry. Okay, every day a bus leaves Everett at noon for SeaTac and another bus leaves Olympia for SeaTac at the same time. Assume that the length of time X is the Everett bus. It's got a mean of 90 and a standard deviation of 10. And the length of time for the Olympia bus is Y, and it is a mean of 105. So it's taking longer to get to Seattle from Olympia on average, and a standard deviation of 5 minutes. So define D in words. If we're taking the Olympia bus time minus the Seattle time, we're finding the difference. So D is the difference in bus times. And we can say a little bit more. It's, how much longer the Olympia bus is taking. How many minutes more? Okay. All right. So that's in words. So find the mean of D. So when we subtract two random variables, we can just subtract their means as well. So the mean of the difference will be the mean of Y minus the mean of X. So the mean of the Olympia bus is 105, and we're going to subtract the mean of the Everett bus. I keep calling it an Everett bus, Seattle bus. It's Everett. Righto. Okay, so 90 minus 105. So the mean difference is 15. So the mean difference, on average, the Olympia bus is taking 15 minutes more than this Everett bus. They're both going to SeaTac. Okay. The standard deviation, a little bit more complicated. You have to square root the sum of their variances. So you have to square the standard deviation. So you're going to take 10 squared plus 5 squared. So that's going to be 125. And then you're going to take the square root of that, which is not too nice, I don't think. At 11.2 minutes. Let me make sure that's what I got. Please hold. What in the world? Phew. It was right. Okay. So here's where I made the mistake. And the one on the test, the combination will be adding. And so this interpretation won't be as hard, but you still can do it. Okay. Over the long run, what proportion of days will the Everett bus, I don't know where I got Seattle, will the Everett bus arrive to SeaTac before the Olympia bus? Okay, so the fact that we subtracted these two, we came up with a new normal distribution that's showing the difference. Okay, difference. And specifically, we took the Olympia bus minus the Everett bus because the Olympia was taking longer. So this number is the amount of time, how many more minutes it's taking the Olympia bus. Okay, that's the average. And let's write the standard deviation over here. Oopsie, standard deviation of D is 11.2, just so we have that. So here's where that weird zero comes in, right? What proportion of days will the Everett bus arrive to SeaTac before? Well, the Olympia bus is typically taking longer. So all of these numbers, as long as these numbers are greater than 0, it means that Seattle's getting there before because Olympia is taking longer. So the only time, so it wants to know when will Seattle get there before. So we're going to go 0. So all of these numbers, anything above 0 means Seattle's getting there before because Olympia is taking longer. So we're trying to find this. I think originally on the key I put this because I misworded that. So we still are going to find the z-score in this percentile and then subtract it from 1. Okay, so we'll find the z-score of 0 minus 15 divided by 11.2. 0 minus 15. Okay, that's negative 15. This awesome craft. Divided by 11.2. So that's a z-score of negative 1.34. Let me get my handy dandy z-check table. Negative 1.34. 0.0901. So, which is, where is that? That's this part underneath over here. But I want to know, so, 9% of the time, just this small fraction of the time, the Olympia bus might actually beat the Seattle bus. But we wants to know, when will the Seattle bus, which is typically what's happening, when will it beat the Olympia bus? We're going to go on this side. So we're going to go 1 minus 0.0901. Let me just make sure I don't make any stupid mistakes. So about 91% of the time, which is this part, right? All this stuff. Okay, 90.99% of the time. All right. Yay.